Hello everyone, and today is 24th of December. So tomorrow is the last day of this Advent of Code challenge and the last day of our experiment. You can see a video preview of what we are going to see today, approximately what the task is about. I haven't read it, but I've just prompted ChatGPT to create a prompt for Sora and then run that, so that we can at least have a grasp of understanding what we're going to expect. So yeah, today we are going to solve as the same way as the previous days. We are going to use AI. This is an experiment of AI, different AI models, how they approach such problems that they haven't seen, because every new year, like every new Christmas, like Advent of Code, is giving us different problems. They are slightly, they could be like reminds of one another from the previous years, but then they are completely new for AI, and we've seen that some of the problems AI, even O1 Pro, haven't been able to solve at all. So we'll see what we're going to expect today. We're going to prompt the first task, the first part of this task, to O1 model, OpenAI O1. Hopefully it will solve it, and then we're going to prompt both of the parts to all the models we are going to test, which are Claude 3.5, Haiku and Sonnet, GPT-4o, GPT-4o Mini, O1, O1 Mini. Also, I'm going to test Gemini 1206 experimental and DeepSeek, which is a Chinese model. So let's firstly read the task, and then we'll prompt O1. Yeah, I think we're going to do so.
You and the historians arrive at the edge of a large grove somewhere in the jungle. After the last incident, the elves installed a small device that monitors the fruit. While the historians search the grove, one of them asks if you can take a look at the monitoring device. Apparently, it's been malfunctioning recently. The device seems to be trying to produce a number through some Boolean logic gates. Each gate has 2 inputs and 1 output. The gates all operate on values that are either true, 1, or false, 0. And gates output 1 if both inputs are 1. If either input is 0, these gates output 0. Or gates output 1 if one or both inputs is 1. If both inputs are 0, these gates output 0. XOR gates output 1 if the inputs are different. If the inputs are the same, these gates output 0.
It's classical explanation of these gates. Let's see what's going to be next.
Gates wait until both inputs are received before producing output. Wires can carry 0, 1, or no value at all. There are no loops. Once a gate has determined its output, the output will not change until the whole system is reset. Each wire is connected to at most 1 gate output, but can be connected to many gate inputs. Rather than risk getting shocked while tinkering with the live system, you write down all of the gate connections and initial wire values, your puzzle input, so you can consider them in relative safety. For example,
let me just paste it here. Okay, so now we can see the videos as well. Okay, so we have those examples. Okay, so let's see what's the explanation for that.
Because gates wait for input, some wires need to start with a value as inputs to the entire system. The first section specifies these values. For example, X00. 1 means that the wire named X00 starts with the value 1, as if a gate is already outputting that value onto that wire. The second section lists all of the gates and the wires connected to them. For example, X00 and Y00. Z00 describes an instance of an AND gate which has wires X00 and Y00 connected to its inputs and which will write its output to wire Z00.
Okay, as far as understood that we have values for those gates or something, and then we have the instructions and we need to compare and then write to these values apparently. Okay.
In this example, simulating these gates eventually causes 0 to appear on wire 00, 0 to appear on wire 01, and 1 to appear on wire 02. Ultimately, the system is trying to produce a number by combining the bits on all wires, starting with Z. Z0 is the least significant bit, then Z01, then 02, and so on. In this example, the three output bits form the binary number 100, which is equal to the decimal number 4. Here's a larger example.
Okay, so 100. How did they get 100? They have four. For 0 appear on 00, 0 appear on 01, and 1 appear on 02. So it looks like it goes from the last to the first line, from the like most significant bit to the least. So I'm starting from 002, Z02, 100, which is 100, and then in decimal it will go. It means 4 in decimal system. Here's a large example. Okay, 1. Oh wow, what does? Okay. So now we have not only numbers but also the letters, which okay, but I see. So we have, for example, we have Y02 or X01, and it goes to T and W, and then if we try to find T and W, we have another instruction, T and W or FST goes to FRJ. Okay, so far so good.
After waiting for values on all wires, starting with Z, the wires in this system have the following values.
And yeah, what we have in result.
Combining the bits from all wires starting with Z produces the binary number 01111018000. Converting this number to decimal produces 2024. Simulate the system of gates and wires. What decimal number does it output on the wire starting with Z?
How did they get that? Did they just they sorted? Yeah, okay, they sorted like alphabetically. And then it goes 00. Yeah, so they start from the last, from the very end. 00111 001, and then 3 zeros here. What? 01000. What? How did they do that? Okay, so there are more letters, more numbers than there are numbers here. So probably, what does it mean? The 00 and 100010. Okay, I see. So only for Z's. So they've used only Z's. Z00Z01. Okay. Okay. Now, as we come to understand this part, we can run our run ChatGPT, and how I'm going to do that. I'm prompting it with the task description, but not only that, I'm going to paste these cursor rules, just a basic information of what we have in our code, like how we are going to ask it to solve it. So here's the example of the file structure, the task set, and it's basically information for us, for ourselves, but could be useful for the model as well. Also, I'm going to select the 2401, and I'm going to paste this template in there, and I'm going to prompt it the same way as I prompted the last time. So like yeah, just let me do that, and I'll read what not it didn't copy. Once again. So solve the task using the template with the input so previous directory, like in root directory, input.txt, write full working solution, full code, not an example, without placeholders, full code that I can run and solve with my input, implement the logic. So it won't be confused, that it won't be returning me some placeholders. So yeah, only fill part 1, so you could understand it only part 1, and I'll copy that, and I'll also select for the next task, for both of the tasks. I'll just place the prompt over there. So I've selected O1 mini file, so it has it in context. I'm pasting the task description, but for that part, what I'm going to do, I'm going to delete the description, because we are going to paste a description for both of the tasks. And I'm going to also say both parts, so it will solve both parts, and then okay, we'll see. Yeah, we see the solution from O1 for the task. So let's see. It's extract lines. It's trying to use regular expression. That is good. By the way, I'm going to add this to our prompt, that so all the models will use regular expressions and not trying to using some other method to extract the values. So use regexp for parsing the input. Also, we need to go back to our advent of code and to get our puzzle input. Let's go back, place our input, and go back to O1, and then place the O1 solution. Let's firstly try to see how it solved it, how it's approached, what its approach is. Regex the initial wire lines, gate pattern. Okay, that's a complex regular expression. Okay, so wire values, gates, parse lines to fill either initial values or gate definitions. Okay, initial match, gate match. If init match, this is initial wire value line, wire name, value string, init match groups. Okay, wire values, wire name, int, integer. So we have values, and that is a dictionary with wire names as keys. So then if gate match, this is a gate definition line, the latest one. Then we have in operator into input 1, in operator input 2, output. It subtracts from regular expression, appends to the lines, to our list. Ensure wires exist in the dictionary so we can track them. If not otherwise, then none. Yeah, you could use default dictionary here. Else, if a line doesn't match either pattern, ignore or raise an error. I'm not depending on puzzle constraint, but ignoring is often safer. Not sure if that's a correct approach here. Okay, so compute, which is going to do the operations and or XOR. Then iteratively resolve gate outputs until stable. So while true, charge false. Again, it uses while true, never, like it uses break, but well, you actually need to have some mechanism to not stuck in a loop like it frequently did, especially in other models, that I'm just not sure whether the code actually supposed to run so long or it just stuck in a loop, and often it just stuck in a loop. So I don't like while true definition here, but yeah, let's see. So in gate value 1 we extract from dictionary, we extract the values. If they're both not none, then we track it to compute result, and then we write the wire values this result. If that's if it's not the same, okay, and we track if it's changed. Collect all values, start with z, parse the numeric suffix, and sort them by that suffix. Then build a binary number from LSB to MSB. Okay, that's what we expect. So for wire values, we match wire, which means z and numbers. Then we extract the index, and then if a z wire never got a final value, default to 0. Okay, no problem. Sort them. Build the integer interpreting 00 as LSB, 01 as next bit, etc. Okay, and then bit value is if ith bit 00 least significant bit. Okay, so result integer, bit value, and I. I'm confused over there, but yeah, should be working correctly. Let's test it out. So let's go into day 24 solutions, Python. Let's run Python 01, and we got this number, and let's see if that's correct. Yeah, we got 1 gold star. Perfect. So now what we're going to do, we're going to read as well the part 2. Let's go back here. Let's read the part 2. But by the way, why won't we do another video generate with Sora? Just let me just one moment to generate a prompt for that. So I have a prompt from the previous one. Let's see what it generates for this one. By the way, I have some videos from the previous for the previous tasks of Advent of Code. If you've been following my videos, or you've been following Advent of Code, you can even try to figure out which is which. And yeah, we have our prompt. We are going to create a new video with a storyboard, and let's, while it's generating, we will find my prompt. Okay, so that's it. And yeah, create. And let's go and close this one, please. Okay, never mind. Yeah, so I have a description for the task 2 and task 1, so both of them. Firstly, we'll read them. We'll read the part 2, and then I'm going to prompt all the models. So let's firstly try to understand the task.
After inspecting the monitoring device more closely, you determine that the system you're simulating is trying to add two binary numbers. Specifically, it is treating the bits on wires starting with X as one binary number, treating the bits on wires starting with Y as a second binary number, and then attempting to add those two numbers together. The output of this operation is produced as a binary number on the wires starting with Z. In all three cases, wire 00 is the least significant bit, then 01, then 02, and so on. The initial values for the wires in your puzzle input represent just one instance of a pair of numbers that sum to the wrong value. Ultimately, any two binary numbers provided as input should be handled correctly. That is, for any combination of bits on wires starting with X and wires starting with Y, the sum of the two numbers those bits represent should be produced as a binary number on the wires starting with Z. For example, if you have an addition system with 4 X wires, 4 Y wires, and 5 Z wires, you should be able to supply any 4-bit number on the X wires, any 4-bit number on the Y numbers, and eventually find the sum of those two numbers as a 5-bit number on the Z wires. One of the many ways you could provide numbers to such a system would be to pass 11 on the X wires, 10 and 11 in binary, and 13 on the Y wires, 11 and 1 in binary.
Okay, again, for this task, while reading only one time, I can definitely say that I need to read like 3 more times to comprehend what the task is about, just from this description. But usually when we read the actual example, when they trying to like solve with an example, it begins to be much more clear. So let's see if it will be so.
If the system were working correctly, then after all gates are finished processing, you should find 24, 11 plus 13 on the Z wires as the 5-bit binary number 11,000.
Okay, 11 and 1000. Yeah, how do you solve it?
Unfortunately, your actual system needs to add numbers with many more bits and therefore has many more wires. Based on forensic analysis of scuff marks and scratches on the device, you can tell that there are exactly 4 pairs of gates whose output wires have been swapped. A gate can only be in at most one such pair. No gate's output was swapped multiple times. For example, the system below is supposed to find the bitwise AND of the 6-bit number on X00 through X05 and the 6-bit number on Y0 through Y05, and then write the result as a 6-bit number on Z00 through Z05.
I have no idea what they're talking about. I'm just completely lost. How do you? Okay.
However, in this example, two pairs of gates have had their output wires swapped, causing
Okay.
the system to produce wrong answers. The first pair of gates with swapped outputs is XA0 and Y0, 05 and X05 and Y05, Z0. The second pair of gates is X01 and Y01, Z02 and X02 and Y02, Z01. Correcting these two swaps results in this system that works as intended for any set of initial values on wires that start with X or Y.
No, it haven't been clear. Haven't been more clear. I think we're going just to prompt the models and see whether it's answers or not.
In this example, two pairs of gates have outputs that are involved in a swap. By sorting their output wires names and joining them with commas, the list of wires involved in swaps is Z00, Z01, Z02, Z05. Of course, your actual system is much more complex than this, and the gates that need their outputs swapped could be anywhere, not just attached to a wire starting with Z. If you were to determine that you need to swap output wires A with E, O with Z99, BBB with CCC, and AOC with Z24, your answer would be AA, AOC, BBB, CCEE, O, Z24, Z99. Your system of gates and wires has 4 pairs of gates which need their output wires swapped, 8 wires in total. Determine which 4 pairs of gates need their outputs swapped so that your system correctly performs addition. What do you get if you sort the names of the 8 wires involved in a swap and then join those names with commas?
So in the result, we need to have like an answer that looks like this. That's the only part probably that I have understood. Yeah, let me just really go through the first section again. So trying to add, so simulating try to add 2 binary numbers, specifically treating bits on wires. It is treating the bits on wires starting with X as one binary number, treating the bits on wires starting Y as second binary number, and then attempting to add this number together. The output of this operation is produced as a binary number on the wires starting with Z. In all 3 cases, 00 is the least significant bit. Okay. The initial values of the wires in your puzzle input represent just one instance of a pair of numbers that sum to the wrong value. Ultimately, in any 2 binary numbers provided as input should be handled correctly. That is for any combination of bits, the wire starting with X and wire starting with Y, and the sum of 2 numbers of those bits should be produced as binary number of the wire starting with Z. If you have an addition system with 4 X wires, 4 Y for Z, you should be able to supply any 4-bit number. So like, okay, 0 is at 1, 0 is at 1, so 1 1. If the system working correctly, then after all gates are finished processing, you should find 24 on the Z wires as a 5-bit binary number, 1 1 1 1 1 0 0 0. So like 1 1, then what? y11 plus 13. Oh, I've missed. I've missed probably one of too many ways you can provide number system. You can bind a system to pass 11 on X wires. Okay, I see now. Or am I? Okay, so if I understood correctly, then we do what? We start from again from the not least, like, what do you call it? Like the maximum significant bit. So from all three, we start and go to 0 0. So 1011, which is this value, which is of all x's, and it will go like it will mean 11 in decimal system, and then 1101, which is here, which means 13 in decimal system. Then if we add them up, we'll get 24, and therefore we have 5-bit number, not 4-bit number, which is 11000, which means 24. So yay. And then some of them are swapped for some reason. Yeah, I won't go into this part of swapping. Sorry, I might be too dumb to understand this problem. So yeah, let's do it again. But for also we have a prompt, our prompt here. Let's also delete the output from the first part, so it won't confuse our models. That it's already solved. And let's solve the past both parts. Use the template. Okay, that seems correct. So we'll try it on O1 mini, in O1 mini file with O1 mini model, and then I'll do the same for O1, and I'll be opening up Claude models as well and all the others. So let's write with 3.5 height here. Let's open up Sonnet. Let's choose formal style. Let's also go to the DeepSeek and Gemini. DeepSeek enabled with DeepThink enabled, and also I'm going to run Gemini. Create prompt, Gemini experimental 1206, and run. Yes, seems like that's all the models that we need to test. Let's see. Yeah, O1 is already giving us an answer. That's interesting. Okay. So let's go. Firstly, let's try O1 mini. So again, it solves both of the tasks. Parse input, parse gate. Why it goes after the main function. Okay. So parse input, parse gate, evaluate gate. Okay. Correct swapped out. Oh, okay. So for some reason, yeah, it won't work. So it definitely didn't solve the second part because it's giving me placeholder implementation. In a real scenario, implement the logic that to detect swaps. For the purpose of the solution, we'll assume gate outputs are correct, since detecting swaps require additional context or data. No! I explicitly said that you need to write full solution. What do you want? Like, I said, implement the logic. Do not write placeholders. I'll probably add, this is a real scenario. And I don't know what to add more. Scenario. And I'm writing in caps because it just works sometimes better for the model. Yeah, I'll just revert it and go again. I'll consider that as a prompt issue, not a model issue, but yeah, you can definitely say that that's a model issue as well. Let's see if the O1 did get us some placeholder. Now, seems like it's implemented the whole solution. Quite a bit of text. You can read it, by the way. I'll send you. So in the comments, I'll post a Telegram link to this post, like to the post with this day, where you can find the YouTube stream link, a GitHub link to this repository. So you can just go there after I submitted code. You can go there and you can see all of this description and try to go through it by yourself. Because if it works, definitely worth getting into and trying to understand the approach. So let's go and paste it into the O1. Okay, and let's see whether it solves it. Hopefully it won't be stuck in a loop. So we get a result for the first part, and seems like it's the same for it's the same as the first time. So it solved the first part correctly, but it takes some time to solve the second part. Let's go and see. Yeah, I see that O1 Mini really struggles with the second part. So simulate, find decimal, identify, yeah, placeholder logic. This requires implementing the logic to detect correct. For simplicity, returning no placeholder. I don't know. I'll. Yeah, it's just too lazy for some reason. Too lazy. No placeholder logic. No. For simplicity, returning as placeholder. Implement the full logic instead. I hope that other models didn't like fall into that problem, because I've already used that prompt before. But yeah, O1 Mini for some reason I have seen this thing from O1 but not from O1 Mini, and now O1 Mini is just giving me a placeholder. Okay, first part, the second part is still calculating, so let's just place all the solutions of other models. Let's start from Claude 3.5 Sonnet. We have the code. Hopefully there is no placeholders. So 3.5 Sonnet. All right. Oh, I love how Claude writes the code. We have data class of gate, and all the functions are separated. All the names are clear. Simulate circuit, wire values, wire dependencies, gate outputs. You can just see that it's much more clear than even O1 get us. But we have on the left on the right part of the screen the solution that O1 mini has that provided us. Yeah, again, for simplicity, assuming part 2 requires identify. Yeah, it seems like it didn't solve it as well. Once more. Yeah, okay. That was the last attempt with O1 mini. So apply swaps if provided. Process gate, no more changes. Get z value, part 1. Try swap combination. Alright, it did tried something. Oh wow, for I, J, K, L, M, and O, P. So try all possible combinations of 4 pairs of swaps. Well, actually, you could do that without this nested loops. Probably there is a thing in each tools, but yeah, okay. So Claude 3.5 Sonnet. Let's see again. O1 mini. What did it get us in part 2? Yeah, okay. No answer. For simplicity, assuming part 2 requires identifying swap gates as problem description, this implementation would need additional logic to detect incorrect swap gates. Yeah, that's what I expected you to do. Due to the complexity, here's a placeholder. I explicitly said, like multiple times, do not write placeholders. I need complete implementation. It just didn't do that. It just didn't do that. Okay. But I think O1 did struggle with this as well, because I have no answer from the part 2. But I'll give it like some more time until we finish copying our code. So this is Claude 3.5 Haiku. Let's see. So, part 2, find swapped wires to prevent correct addition. The right wire values, connections, parse input, then swapped wires, find swapped wires. So there is something. Part 1, simulate gate system, produce the output. So simulate gate system. Okay, collect z values, z wire values. Convert binary representation to decimal. Yeah, seems like correct one. Okay, so we have some logic here. Find swap wires. Yeah. So wire values, gate connections. Okay. So what I meant from ET2's import combinations. So it's like a more neat approach. Find all potential output value wires. Output wires for connection, gate connections, match search. Okay, output values, sorted list. Try swapping different wire combinations for number swaps in range up to 4 pairs. For swap combination in combinations, create a copy of gate connections, perform wire swaps. Okay, so at least there is some logic. At least even in Claude 3.5 Haiku. Okay, so Claude has finished. Now DeepSeek. Do we have placeholders here? I don't see any. There is logic like to determine the swapped wires. Okay, and there is logic. Okay, so seems like a complete code here. I'll need to add DeepSeek. Gemini. Yeah, and again, seems like a complete code. I'm not sure if correct, but at least it's complete. Okay. Okay, and what we have left? I think we have only GPTs, GPT-4o and GPT-4o mini left. And apparently seems like O1 didn't solve it, because it just takes too long. So GPT-4o mini, let's create another composer. select O1 as GPT-4o Mini and submit. Okay, again, I like the approach with the classes, gate system, parse input, evaluate gate, process gate, get result. Okay, gate system, parse input, process gate system. I like this clean code from GPT-4o Mini. I haven't expected such code, but yes. Again, you can see that it's just OpenAI models that are really lazy models. Even when you explicitly told them multiple times that don't write placeholders, implement the logic, it just keeps doing this. We need to implement the logic for swapping gates. Yeah, that's what your task was. Okay, let's see if at least you figure out the first part. Lazy thing. Okay, let's see if GPT-4o will solve it. GPT-4o, let's check if my prompt is... yeah, implement the logic. Yeah, no place holder solutions. Implement full logic for swap. I'll prompt it directly. Swapping gates 2. Okay, and select GPT-4o. Oh, in agent mode. Okay, no problem. Hopefully it will get us something. Okay, no, it didn't. Stupid model. Stupid model. Yeah, I won't be giving you any more chances. I'll probably give another chance for O1 because I don't see any answer from that for the past part 2. It could be that no models did solve the second part correctly, so we'll definitely need to do that ourselves. Like not to do ourselves. I mean to do it again with O1 Pro, because there is hope that O1 Pro will solve it. And now, as we've finished filling all the solutions, yeah, that's what I meant. It just could be stuck in a loop, and we just don't know whether it is or it's finishing the solution. So okay, let's firstly write O1 success for the first part. Failed for now for the second part. Now let's test GPT-4o Mini. GPT-4o Mini. Okay. Didn't get the first one. Why? So result 0. Soften virus. Process gates. For input operation, so gates. Parse input. Gates bend if match. Could be that the regular expression is incorrect here. Let's just see. Print. Yeah, it's correct. It's correct. Let's just print wires. Yeah, seems like correct one. So process gates. Print process gate. Okay, so it did calculate something. Where was the problem? Yeah, just print Okay, so if Z and this stuff in self wires what are the wires as well? Again, ZOO. So there is something. There is some problem in that condition. Let's, what should we do? With just if Z in wires. No, it didn't help. In wires. So it should check the keys. If Z in wires. Result print. ZO 35. Okay, no. If Z in wires. Remove this part. Yeah. Seems like Z in self wires. Yeah, I'm not sure what's the problem, but yeah, nothing is solved. Failed. Then let's go with Claude 3.5 IQ. That's incorrect. And it calculates the second part, but yeah, if it gets first part wrong, probably it will get the second part as well incorrectly. So what's next? Yeah, so let's say failed and failed for now. Let's test GPT-4o. Okay, so it didn't even get us the first part. And the problem is something with parsing. Okay, so yeah. I have no faith in GPT-4o at all. It always gets some, like, not always, but it so frequently gets us mistakes in code. Like if it's not runnable, or like not in problems in logic of solving the task, but logic that should, like the approach is not runnable. It's like you can just say like it's not compiling even the code correctly. It's not solving it, but not compiling it. But Python is not compiling anything, so just as an analogy. So yeah, so failed for both tasks. Claude 3.5 Sonnet. Okay, we have something for the first part, but I think it's not the correct one. I don't remember the exact figure. Oh, where was I? Yeah. Okay. Yeah. 518. Yeah, it's not correct. No points for you, Claude. Failed. Seems like it again. It just takes some time to solve the second part, which is probably it will get incorrectly as well. So again, let's for now state that it's failed. O1 mini. We did try it, haven't? Yeah. Okay. So there is an runtime error. Cannot resolve all gates. Possibly dependency issue. In which part? In part 1. No, you did solve it incorrectly with many more times, like failed for you. Yeah, I won't be testing you. Okay, so Gemini. Okay, we get a correct answer from Gemini for the first part. That's good. I'm surprised that Claude didn't get it and Gemini did. So yeah, like interesting. I would really like to try another Gemini model which is a thinking model. Delete. So Gemini 2.0 Flash Thinking Experimental. It should think before it gets the code. Here's a description, part 1, part 2. Detailed implementation plan. Optimization for edge cases. Wow. Refinement for part 2. Okay. That's really cool. I'll be very surprised if if Gemini thinking model will get it. Where's that? Yeah, that's it. So here's the full code. Okay, let's see. Yeah, sorry, Claude. I won't be giving you any more chances. I'll create another Gemini 2.0 Flash Thinking. Okay, yay, and let's run it. Gemini 2.0. Yep, that's not a problem. Okay, no, it failed to even solve the first one. Yeah, okay. Thinking. Yeah, sorry, Gemini. You didn't think through. Okay, so Gemini is still thinking on the next. So trying to solve the the second part. IQ, yeah, sorry, IQ, you failed. So Gemini, success for the first one, and probably failed for the second. And we have a DeepSeek as well. Let's see what DeepSeek has. Incorrect answer for the first one, and a definitely incorrect answer for the second. So yeah, it's failed. It's a failure. Quite a complex task for all the models. Okay, so not so many models solved the first one, so only Gemini and O1 solved the first one. The second one was a really problem because even O1 didn't get it. So I'll just be closing everything except O1, because I'm going to do this with O1 Pro. And let's refine our prompt so it won't get us anything like placeholders. Okay. Okay, so let's solve. And I think it will take like a few minutes to solve this. Those are our gates. Swiped. Well, at least we get the first part. Let's see what were the results. Leaderboard 25. Okay, so first 100 users to get both stars, which is 18 seconds. Oh no, sorry, 18 minutes. I'm mistaken. So 18 minutes. Yeah, this is, yeah. So the 100 solution is 1 hour. So people really struggled with this. This is a card problem. And you can see that the first star, it's 9 seconds. 9 seconds. It's like, I think it could be possible with script only. Probably like that parses the website, parses the input, all going automatically, not even copying the prompts to the O1 and then running it. I think it was completely automatic, so that those people who solved it first star under a minute, it's definitely there that they are using AI. And this is a more real time, I think, like 4 minutes, 5 minutes, and most of them 5 minutes. And this is the first star, but both stars. To get both stars, the first person got it in 18 minutes. So that's a really smart guy. Did he appear in the first? Okay, so he solved the first task in 4 minutes, and it took him like 14 minutes to solve the second. It's still quite fast. We'll need to wait for some more time. It really struggled with this one. It almost finished, but yeah, I think it's like how much time did it last? Like I don't know, 4 minutes, 5 minutes. Okay, we have an answer for 7 minutes. 7 minutes. Reads puzzle input. Parse input. Part 1. Initial wire values. Gate definitions. Okay. Regular expression is correct now. Simulate circuit. Because there are no loops, we can keep tracing until no changes. A more efficient approach would be a topological sort, but let's do repeated passes for simplicity. Why do you need simplicity? You have all your time to do topological sort. Gathers all wires, then start with Z, sort them by numeric suffix. Okay. Part 1. Part the circuit simulated once with the given initial values and return decimal number. Okay. Part 2. Gather wires and gates. Okay. Sort them by their numeric suffix index. X wire sort. Yeah. Well, there's a special thing for special sorting function. XYZ. Then simulate with force inputs, similar to simulate circuit, but force input is a dictionary of wire that overrides any initial wire values from the puzzle. Get integer from wires. Given final wires dictionary and a sorted list of wires, lowest bit, highest bit. Okay, this is the how they call. Produce an integer. Check header correctness. Checks if the given is implement z x plus y in binary for a subset of possible x and y inputs. If the circuit is large, we won't test all combos but a subset that would catch swaps. If it passes all tested combos, we'll say true else false. Okay. Nx length. Okay, so number of x, number of y's. If nxy is large, we can test all combinations. That's correct. We'll do a small subset. That's really smart. We'll build a list of interesting test inputs, focusing on small numbers, extremes. Always test small range for k up to. Okay, limit. We won't exceed 2 in the power of nx. We'll choose example. Okay, find swapped pairs for adder. We know exactly 4 pairs of gates have had their output wires swapped. Gate output can only appear in at most one swapped pair. We'll attempt potentially large backtracking search. We'll consider all pairs of gates. We'll try picking 4 distinct such pairs to swap the outputs. After applying those swaps, we check if the circuit is correct. Yeah, now I see why all the other models were too lazy to solve the second part. Not all of them, but the smallest one. Just, yeah, they need to really think it through. Backtrack. Okay, that's quite a bit of code. Let's test. 01 and 01. Maximum recursion depth is exceeded. Well, actually, first one is correct. Let's set import sys set recursion limit. Let's increase it, like, I don't know, at this time. I won't be waiting for too long, because again, these tasks are expected to be solved, I think, in like a 1 minute, probably, on a standard computer. So it shouldn't be taking 10 minutes or 20 minutes to calculate. It's probably again an issue with all the logic. Okay, Gemini didn't solve it. I still have some hope for O1 Pro, but seems like it didn't get the second part. And to be honest, I have no idea even how to do the swapping. Like, I didn't even get what the task is about. Like, second part, the swapping thing. What's this? Undefined. Why? Undefined name. GI, GJ, GI, GJ. I think it's like, it should be like that, but it didn't even get to this place. Yeah, okay. I'll be stopping it. Let's state. Okay, so it's, yeah, I finished filling up the results. So, okay, so we have our result that none of the models, even O1 and even O1 Pro, didn't or was able to solve the second part of this problem. So I'm not getting where the calendar. Unfortunately, I'm not getting this this to be like filled in with colors, but I do really want to have this. So yeah, you know, I'll just submit and go to subreddit and try to find the answer. Years of training paid off. What? Okay, day 22. Wow. Official survey results. What's that? Day 23, day 24, crosswise comic strip. Oh. Okay. Okay, I want to remember to return. Function returning none. Is that stupid? Okay, solutions. Use reminders. Okay. Slightly. See content megas provided rules. Crosswires. Full posting rules. 8-page language solution. Cross spaces. Okay. Part 1. What's that? Day 24 solutions. Where are those? What to? It's so easy. Is it? Supple. Okay, it's using some. Okay. Can I like ask to use this library? Maybe it will get this by itself. No, incorrect. That didn't, like, it takes too much time, and also the recursion limit should have been increased. Use for solving the second part. Okay, let's run it once again. We're still waiting for the solution of O1 Pro with graph flip, because it didn't solve it itself, like using just pure Python. We have some solution which supposedly works. For like, what's by the way? In refind read open 0. By the way, what does this thing? I've seen multiple times people do open 0 read. What does it mean? Let's ask it in chat. What does do? Opens file descriptor, which is a standard input in Unix systems. Numbers 0, 1 and 2 special descriptions. Standard input reads all data from the standard input until it reaches end of file. Reading input that is piped to the program. Okay. Read input redirected to the file script input. Okay. Okay. Cool. So it's another way to run the script. Okay, that's nice. Oh, we have an answer. Cool. For the part 2 as well. I don't. Yeah, it's much more like it's much bigger than that we've seen before. Like this is the actual solution. Let's submit the solutions of the update result for day 24, and I'll try to do this. Okay, so okay, parsing. Let's try again. So first one again is correctly solved. Second one is just giving us nothing. Okay. Okay, so seems like O1 Pro really struggles with that. Let's do it another way. So I'm just copying the correct solution. Test 1, test n, while lang. Let's do how did it do? So Python, and where was it? Input.txt, input.txt. Would I be able to solve the second problem with the completed solution? With a ready solution? I wonder how, like, what was the problem? If it's able to solve, what is the problem? Why O1 didn't get it? Let's prompt it. No, it returns nothing for the second part. Here is the correct solution. See and explain the code and why it works and yours isn't. It's not. Okay, isn't. And yeah, it's still trying to solve. I hope. But it takes too long. Okay, we have an answer. Oh, I really hope that will give me this second star. Yeah. Okay. Sorry, I really wanted to get this filled. What's the 21st task? Why is it not filled? Oh yeah, because alright. Yeah, no model did solve the 21st day. No model, none. I think I can do the same for the first one, for the 21st. Like, okay. Subreddit. Let's try to find. Okay, we're at the same page. Do we have 21st solution? Okay, 24. No. Okay, because it has something here. The 21. It's still thinking. Okay, day 21. 21 solutions. Let's see. Rust, JavaScript, C#, Kotlin, C++, Python. Okay. Paste. Okay. Wow, that's quite a bit. Okay. 21 solutions. Reddit. And hyperclip. No, thanks. Print C, print Y. What does it do? Pinterest. No, thanks. So dot input. Print C, print. So like doing print copy, I don't need it. Okay, let's go to the day 21 solutions, Python, Reddit. No, I don't need this one. What does it do? Okay, what's the sign? What? Push import from AOC tools. Should I just install it? Okay, let's see if I want pro. Okay, we have a solution for, like, not solution but explanation. Explanation of correct solution. Okay, they provide the code. What the code does. Reading the parsing gates. Okay, determining bit width. It looks like all wires named Z find maximum. Name Z to find maximum used for Z. C maximum means the highest Z is Z12, then C equals to 12. Thus, there are at least C plus 1 bits relevant on the Z side. M equals to, this is a number of C plus 1s in binary. Example, C equals 4, M equals 31. This function evaluates the circuit with specific input numbers x and y. It first preloads wires x's, similarly for y's with the bits x and y. Then it iterates over E, which is the topologically sorted list of wire outputs, and performs the operation and XOR on each gate to compute value of wire. Important, it uses as get to see if wire is swapped with something else in the dictionary. This is how it injects the swapping outputs logic. Once done, it checks bit by bit whether the produced Z bits match the actual x plus y bits. If a mismatch found at bit I, it returns I. If no mismatch found for any bit 0, it returns C plus 1. Means perfect up to bit C. Test N builds a topological ordering of the circuit using topological sorter, but with the current mapping swaps as considered. Then it runs the circuit on small tests of input pairs. It runs the minimum mismatch, building swap dictionary. Initially, why it works. Greedy improvement. Each time we add a new swap pair, we pick the pair that yields the best higher correctness measure for the circuit. The function test precisely returns how many bits are correct in the first failing bit across multiple test inputs. By maximizing the return value, we gradually force short circuit test. Code tests only. It's a small set, but these test pairs do a good job of checking edge cases. Example, if all bits set, no bits set carry edges. If the circuit can handle this case fully, it almost certainly correct as another. No giant brute force. This approach is much more efficient than trying always of choosing 4 disjoint pairs from large set, because it greedily picks each pair that yields a bigger jump in correctness. Topological circuit puzzle states no loops in the circuit, hence topological circuit can produce valid ordering. If a swap introduces a cycle, it tries wire a gate output back into itself in a weird way. The code catches it where this error and penalizes that choice. Why other approaches might fail or return nothing? Too large of search. Testing the circuit, not maintaining good partial swap. Puzzle states exactly 4 pairs of swap. If a solution tries randomly or backtracks incorrectly, it might keep guessing pairs that don't fix the sum. Without well structured scoring the correctness metric, each partial step can get stuck, reverted correctly, or never zero. No incremental. So summary. Your code uses greedy iterative approach. It discovers swapped pairs that improve correctness bit by bit. Well-designed function, topological sort wide works. By always picking the pair that yields the largest correctness increase, the trebling converges on the 4 correct swaps. Why? Okay. So, yeah, it's something like more. From is import. So yeah, as a result, I didn't do like 50% of this. That was a really smart guy to use this code to solve the second part. Congratulations. And yeah, I'm not leaderboard. Here's our calendar. Here's what we solved. Not all of them, all the problems were solved by the AI, especially the day 21 that I'm going now to try to solve with AI again, with the correct answer, but just fixing without the AOC tools. So yeah, thank you for watching, and you can just stay around with me while I'm doing. But yeah, we've finished for day 24, and I'll see you tomorrow on the Christmas day, 25th of December, where we're going to solve the last day of Advent of Code, and I'm going to produce a table comparison of all the models solutions. Or I'll just show you that. So, fix this code. I don't have AOC tools, and I don't want to install it. So there's hipq push, hipq pop, DD default functionality, assign, return the assign number. Okay. These guys are really smart. Okay, let's try. We have our first number. First number, which has a gold star. Cool. And the second number. Alright. Oh, that was tough. Okay, I have it filled. What is that? I wonder if AI will understand what's happening here. Let's try, by the way, with O1. Explain in details what the image is about. Analyze like thoroughly. This image is decorated piece of ASCII, too large one. It's not 11, it's 10. Appears to be celebrating a bit of code, festive, yeah. Along with nods to a 10 years anniversary. Ah, okay, so that's why it's 10. 10 years anniversary of Advent of Code. Overall shape too large ones, no. Outline too big, rectangular shapes, borders with shaped dashes, colorful decoration symbols. Reference of code, detailed ASCII flourishes, so tablet swirls, small shapes like miniature scenes of code snippets, middle sections, dots, plus sign, bracketed, mosaic, light up, loop. Some lines spell partial words. There looks like textual designs. Near the bottom, on the second one, you can see more words: AOC, 10 years, and so forth. By the way, yeah, okay, 10 years. I now understand what's that mean. Okay, theme and purpose. It's actually not 11 but 10. I identify all the small piece, like a small, how do you say, small shapes inside identify and name and describe all small shapes inside the 10 ASCII part. So left digit. Sounds and swirls, waves and wind. Repeated letters E and 8 sign. Tiny clusters, decorative flourishes, parentheses and brackets. Pretty little faces. Faces. Where are those faces? Is that it now? Stars. Floating lights. Yeah, looks like it. Midsection. Box window shapes, rectangles formed by underscores. Mini control panel. Might be asserted dots, punctuations, pattern lights like the one. I don't think so. Vertical runs of characters, columns and green colors that might resemble strings and lights, code blocks. Well, it might be. I'm not sure. More like I don't know what's that. I have no idea. Lower section. Parentheses, bottom round shape, curved text fragments, some round shape. No. Partial letters. Shape in blue. No, it's a cup. I can see that's a cup, and this is a hat, and this is. I'm not sure what's. The crucial. So yeah, I didn't get this part. Okay, right digit 0, colorful line, circle, colorful circles and angle brackets. Right red bean goes ornaments, all lights. Yeah, well, actually, this is definitely a Christmas tree. Starburst, sun like ASCII. No. And it didn't see the reindeer. ASCII mountains, trees. Mountains and trees. I don't see any. Okay. ALC to 10 years. Okay, that's correct. Lower arc. Doesn't shapes, curves and underscores. Symbol like fish, comedic images. Right side star listen time. Yeah, this is not it. Okay, so yeah, it's incorrect. I wonder if Claude will get this one. Let's see. So okay, and explain the details and more thoroughly. Okay. So, top left panel features complex patterns, symbols and sides, wave-like flowing like top, center panels, angular patterns with forward, backward slashes forming triangle shapes. Where? Top right panel shows geometric dashes and slashes and organized arrangement. Yeah, but what does it know? These patterns represent some shapes from real world. Try to get all shapes. Example: there is a reindeer. Okay, top panels, reindeer constructed from slashes and dashes with antlers visible. What appears to be a snowman made from circle characters and dashes. Snowman? Could be a snowman though. I think I'm not sure I see it. Star patterns, yeah, night sky, snowflakes created using asterisks and special characters. Might be. In the middle, Christmas tree shapes formed by slashes and vertical bars. I'm not think so. Moon shapes created using parentheses. Falling snow, white dots and tides. Tildes. Geometric present gift boxes. Geometric. Where's the gift? Where's the gift? I don't see any gifts. Okay, bottom panels. So it should be somewhere over there. No gifts. Yeah, seems like I didn't get it. Okay, now I think we'll need to wait for all three to be released to understand fully this picture. Okay, anyway, thank you for watching. Thank you for staying with me, and I'll see you on the next one tomorrow.